Hello, everyone. Welcome to UnleashCon. We are so excited that you're here. My name is Melinda, and I'm the documentation team lead here at Unleash. And I'm very excited to be your host today. We've got a fantastic lineup today. You'll be hearing from some of the largest retail and e-commerce merchants and financial services, and some teams pushing the boundaries of AI. And it's genuinely one of my favorite times of the year here at Unleash, when we get to hear from all of you amazing engineering teams and see how you're using Unleash in the wild and how you're solving some of the most interesting challenges in software delivery. So very excited to see all of the talks today. We'll also be taking a short break about partway through the program. So you'll get a chance to stretch and recharge. And yeah, just overall very excited to get started. And one common theme today, as you'll notice throughout the talks, is feature ops and how teams are going faster without sacrificing kind of their resilience and safety. And with that, I'd like to welcome Ivar, who will give us his perspective on feature ops and where Unleash is today and what's next. Hi, Ivar.
Hello, thank you so much. So I'm Ivar, I'm the founder and CTO of Unleash. I'm here today to talk about feature ops and how it enables teams to go fast, but also take control of the quality and make sure that you also build quality software. I will also touch a bit upon what we are investing inside of Unleash in terms of the product to strengthen the position of Unleash being the control plane for feature ops. So we have a mission here at Unleash, and it has been the mission from day one. We want to make life easier for developers. We know that building software in big enterprises, in established companies, it's really hard. There's a lot of dependencies. There are microservices that you need to integrate with. There are other teams that you need to collaborate with in order to succeed building great software. In addition, pushing to production, even though we have thorough testing, we have our unit tests, we have our integration tests, pushing these changes to production is still a risky affair. The risk is that we upset our users first and foremost. So we are building new stuff that we really want our users to be excited about. But sometimes things goes wrong and it impacts users in production. And it can also obviously impact our business. It could impact our revenues and all of that in addition. And this is why it's so important for us that we exist, because we want to make this life slightly easier than it was before. But how can software teams actually go faster? Luckily, the industry has standardized around DevOps. DevOps is the core fundamental on how teams can ship software in a predictable, fast, and reliable way. And we don't want to go back to the time before DevOps, where we did a couple of releases a year. It was these massive release days that ended up being this release weekend, that ended up being this release weeks, where we just had to do massive patches all the time into production to make our application back as stable as possible. This was not a good time. So DevOps has solved a lot of these things for us and made it slightly more easy to be engineers and pushing changes to production. But how do we know that a company, organization, or a team has successfully adopted DevOps? This is where the DORA report comes in. This is an annual report on the state of DevOps. This is a survey where they talk to engineers across thousands of engineers across many different organizations of any size, like big, small. And what they're looking for is, how do these companies actually operate? What do they care about? What do they do? And what they found over the 10 years that they've been doing this survey is that there are 4 critical metrics that really matters in order to succeed with DevOps. So the first and foremost is always the change lead time. How fast can we actually go from building something, writing some code, and deploying that into production? The other thing is about how often do we actually deploy new changes to production. But it's also about the quality, and this is where the 2 last one comes in, because it doesn't help if we change production all the time if we introduce a lot of errors. So they also look at things like change failure rates. So how often do we actually introduce bugs in production? And when we do introduce bugs, how fast can we actually recover from these bugs to get back to a healthy state with our applications? And what I found over these years in this report is that companies that do extremely well on all of these key metrics, they tend to also perform very well commercially compared to their peers not performing well on these key metrics. Over the last years, we have AI coming into the door, and it's changing everything again. It's amazing how fast you can build new capabilities today with AI, generative AI, and you can have an idea and have code written for that idea in just a matter of seconds in some cases. And it's changing the game. It's putting more pressure on how fast we should deliver software. But it's not just about writing the software. It also improves other part of the software building process. So it can provide feedback on your changes, feedback directly on the PR. It can write tests for you. It can validate your test. It can summarize changes. And it's also proven to be quite helpful on the documentation side. DORA, earlier this year, they also released a very specific report in terms of the impact of generative AI on software development. And in that survey, 75% of the teams that actually adopted AI in the building process reported that they had an increased productivity because of that. And particularly highlighted in this report is actually the things around building code, but also the building code part. So documentation quality increased, the code review speed was improved. And other research papers has also looked into this impact of AI on software development. And what seems to be coming out of a lot of these researches is that it's very good at low complex tasks and non-complicated environments. But in these complex tasks in very complicated environment, typically in very big, large enterprises, it still has a positive productivity gain, but it's much, much smaller than obviously on the low complex scenarios. The flip side, however, even though it's improving our productivity, the flip side is that DORA also identified that for every 25% increase in the adoption of AI in a team directly result in a reduction in delivery stability, a 7.2% reduction, meaning more errors hitting production. So we're introducing more bugs, but it also takes longer to recover from these bugs. So on one side, we increase productivity, but on the other side, it's hurting our quality. And we can only form kind of hypotheses on why this is the case, but it's intuitively, to me at least, it's easier to create bigger chunks of change sets with AI because you get so much help and the speed is just massive. The challenge with that is it's breaking kind of one of the fundamental principles coming out of the DORA report that teams that perform well, they tend to keep the batch sizes small. So when we increase the batch sizes, we are doing more changes, more risky changes, and it's hard to foresee all the edge cases that could arise in a production environment, leading to more bugs. So to summarize, AI is making us more productive, and the DORA report kind of they found evidence on this, at least from the surveys. Teams are reporting productivity gains, but it seems to also impact the quality. So it enables teams to go faster, but we still need to validate our changes in production. We still need to make sure we deliver software with the right level of quality and it has the desired impact. And in order to take full advantage of the speed that comes with DevOps and AI, we need to balance that with control and quality. Because software doesn't build itself. It's even assisted AI. It is people who build software, and we cannot kind of forget about that part. And this is where feature ops come into the play, because DevOps revolutionized and redefined how code reached production and made it faster, more predictable, and reliable to ship code into production. Feature ops, on the other hand, it redefines how functionality becomes available to the users in production. It gives us this runtime control of our application in a production environment, allowing us to test on a smaller group first, allowing us to measure the impact of the changes before we make it available to everybody. Feature Ops has 5 critical pillars. So the first and foremost, zero trust feature governance. This is about RBAC, SSO, audit logs, change control mechanism. Basically making sure that the thing that we allow to control our applications in production is secure, but also have the required compliance and validations that enterprises need in order to keep control of the changes. And then we have controlled feature release, full stack experimentation, surgical rollback, and feature lifecycle management. And I will dig a bit deeper into all of these pillars and also highlight some of the capabilities we're building in Unleash right now in order to strengthen Unleash as the feature ops control plane. So the most basic one is the control feature release. This is what feature flags typically are about. It is meaning we have now the capability to decouple the process of deployment of code to a production environment from the release of those features. And this enables us to test in a small group. We can test internally on our own team first before we even make it available to any external users in production, allowing us to validate that it actually works, that it works with production data, with production integrations. It also enables us to get early feedback, and we can enable it for less critical user masses first to get that first impression if we have understood the problem, do we have any errors and all of that. And then we can gradually increase the exposure to more and more users. Surgical rollback pillar is about the ability to turn off things very specifically. And this is important when we take full advantage of DevOps and when we take advantage of AI and we move faster than ever before. We will do a lot of changes to our applications in production every day, every week. And suddenly we might detect that something is not behaving the way it's supposed to do. Maybe it's an edge case just for a very specific user group. And in the previous days where we didn't use feature flags, where we didn't have features, we had to roll back the entire application to a previously known good state. The challenge is that that is not an option anymore because we already have 10 other healthy features that we enable for users, and removing those means that the users will get a more terrible experience. It also means we might lose revenue, and it can also be very time consuming to roll back the entire application to a previous good state. What we can do with feature ops instead is that we can go in and just disable that specifically, that feature that is not behaving. We can even disable it for those users it's not working exactly as it's supposed to. And then we can find a solution for that problem, roll out that fix, and enable it again for everybody. But then we are keeping all the healthy features, which makes a better experience for everybody. Feature flags gives us runtime control of features in production, and it enables us to gradually release those features to our users. But then we need to measure the impact across the entire stack. Are we actually, it's not enough to only observe the error rate or the performance or other kind of metrics that the engineering team cares about. We also need to validate the impact on the best business. Are we hitting the product KPIs that we're seeking? Are people actually adopting this new capability that we invested in? We also need to validate that we implemented it in a way that makes sense for the user or the customers. The voice of the customers is also very important to validate. And it's all these 3 different dimensions that we need to look into when we are building or improving capabilities in our system. And this requires collaboration, of course, between different stakeholders involved in software development process. One of the internal projects that we are building out right now is the impact metrics. So this is a new capability where we want to go deeper in the full stack experimentation space, where we want to make it easy for teams to integrate the metrics they care about for a feature internally, to make it easy to understand whether we are having the impact on the 3 different dimensions that we care about for this feature. So we can easily see what is, do we introduce more errors with when we enable this feature? Do people adopt this capability? What is the conversion rates? What is the memory usage, or what is the overall response time for this capability? Making it easier for software teams to have all the information they need in the same place in order to make decision. Are we going to increase the rollout of this feature, or do we need to iterate a bit more before we can take it to more users? And the vision for this capability is massive. And the first step is obviously to have the metrics inside of Unleash, but then obviously to be able to correlate things that you do inside of Unleash. When you start increasing it to more users, how is it impacted the customer effort score? How is it impacting conversions? And how is it impacting conversion versus people not being part of this new capability that we are working on? And these are things that we are going to build out over the future of Unleash. The last pillar of feature ops is the lifecycle management. It's very important that when we have a tool that allows us to really control our features, that we also really understand the process of how we work with these features and where we are, to make it easier to navigate, but also to make sure that we keep technical depth in control of the technical depth. And typically what we observe across our customers or across users of Unleash is that features tend to go through defined stages. First, we start kind of by defining them, we start writing some code, and it starts becoming available in an early test environment. At some point, and this varies a lot from customers to customer, how fast this happens, but at some point this feature hits production, meaning we are turning it on. It might be in production for a long time because of DevOps and we ship kind of the changes behind a flag we haven't enabled. But when we enable it in production for the first time, that's when we consider a feature to be in production, because that's the first moment where we can start collecting feedback on the behavior of this feature. And then we work ourselves through kind of the production environment, and we do improvements, we roll it out to more users. At some point, we are done with that feature. We might decide to keep it or drop it, but at some time, we are ready to clean it up from the code base. We are ready to remove that code. And when we've done that, we can archive that feature flag. It's so important to be, and this is very deep, close to my heart, because what we see from the data, and we have a lot of customers, is that for every flag that is removed from Unleash, 2 more are created. And obviously this is okay-ish today, and it's not a big problem today, but obviously in 10 years from now, it means there will be a lot of stale feature flags out there. And this is technical depth in the code base. It means it's protecting code paths in your applications that probably are not needed anymore. It increases the complexity of the code bases out there. And it is an intrinsic risk. What happens if somebody decides to turn off this feature or turn it on or whatever is the current state of that flag? So this is also why we are investing more in technical depth management. And already now we're using the lifecycle information. So we model out all the stages, understand where you are in the process. And we will use that data now to nudge the users. And we will tell you, like, it looks like this has been in production for quite a while, 343 days. Are you sure it cannot be removed from code? And then we start with this nudging, and then you can mark it as complete. And that is perfectly safe to do. This is just a signal to everybody using Unleash that this is ready to be cleaned up. Let's go fix that problem. And this takes me to another very exciting internal project that we are running at Unleash right now, because we think we can automate the cleanup process. And it all starts inside of Unleash as part of the lifecycle. So we start by marking this feature as, okay, it's done. We decided to keep this feature. And what happens now in this internal setup is that we will now create an issue in our open source GitHub repository. And you can actually go to our open source repository and look for these type of issues, where it's automatically created from Unleash, where we say this feature flag with this name has been marked as completed in Unleash. We also claim, like, are we going to keep it? Are we going to drop it? If we keep it, we will also identify if it has a specific variant we want to keep. And then we suggest what is the cleanup process for this. And the idea, the next step there is, obviously, we also built a bot that is driven by AI, and we integrated it with the Gemini LLM. You can integrate it with other LLMs like the OpenAI, for instance. But the thing is that removing a flag from code is actually a low complex task. It's very repetitive, and with clear instructions that we already provided in the issue, this is a trivial task for AI to actually do. So what it would do is it would pick up that issue, it will look at the description, and it will try its best to produce a PR to remove it from code. And it will remove the flag, it will refactor out all dead code paths and commit that PR. And in Unleash, and you can go look at this again, we have a lot of these PRs already closed, and what we run obviously all our test cases on this. We will also have an engineer go look into this PR. We can even test it in a playground environment to validate that if we are uncertain that this is a healthy change. So here, and a developer needs to approve the change. But when that happens, we can deploy it into production, and then the lifecycle mechanism inside of Unleash will pick this up after a few days and identify that, oh, we don't see this actually being used in an environment anymore. So maybe you should just archive this flag. It seems like you're done with it. Release management is another capability that actually just moved into GA last week. And this is about as we have identified how people actually roll out features in production and talked with a lot of our customers. And what we identified is that there are certain patterns, like you have the typical activation strategies and you go through certain stages as part of the production rollout. And it varies from team to team how you actually do it, but it tends to be certain patterns that team use. And then it actually is quite tedious to reconfigure manually the activation strategies every time, remember the correct constraints and all of that. So what we're doing is to standardize that in form of reusable release templates in order to make it a lot more efficient to then roll out something in production, but also to reduce risk and increase collaboration. So how this looks like is that you start by defining a template. In this case, it's 25% rollout for our pro customers. So we have a segment of pro customers, and we just define 25% rollout, and then we have 50 and 75 and such. So we define this template, but by defining this template, we can now use it across all our feature flags. So we don't have to reconfigure the activation strategies every time. We can just select this template, and when we apply it to environment for a feature flag, it becomes a release plan for this feature. And this makes it a lot more visible. Like we have these high-level milestones, it's easier to get a very quick kind of understanding of where we are in the release process, which steps we need to go through, and how far away we are from completing all the steps that we need to do, all the validations we want to do. It also makes it a lot easier for stakeholders that needs to manage flags across multiple projects to get the quick overview of the features they care about in terms of where are we at. And in this case, the first one here is actually paused. And it makes it very fast for them, the stakeholder, to reach out to the team member or the owner of this flag and just ask, why did we pause this? What was the learning here? What are we fixing now? What do we need to do to progress this release? So it makes it a lot easier to communicate when we have these predefined milestones. It makes it just easier to work at this abstraction layer. But we have so much more plans for this because we have the release plans now. We are working hard on getting the impact metrics. And when we combine these two, we actually have the ability to start thinking about autonomous release plans. So this is the next step that we are working towards for the next year for Unleash, where we can take the impact metrics and we can combine it with the release plans, and then we can start automating by using the impact metrics in order to progress the release automatically instead of having people to manually click the button to progress to the next step. This is a very high-level sketch from me on how it looks like in my head. So you have kind of the release plans, and then you have some metrics you care about. And in order to progress to the next milestone, we need to wait some hours, but also we need to have the hours that we track for this below certain numbers. In this case, it needs to be less than 20 hours per hour. And if that's the case, we can safely automatically progress to the next milestone. But if that's not the case, then we should actually trigger an alert to the team that cares about this feature so that they can attend to it. We can even automatically disable this feature flag altogether, depending on how risky this feature is for us, so that we can go assess the metrics before we decide whether we want to keep the rollout or we need to do some improvements. So a lot of exciting stuff. I want to summarize with Unleash is the feature ops control plane. It enables team to go really, really fast, but still keep control and quality, and making sure that we are not just shipping fast, but we are shipping high quality software with the right level of quality. Thank you.
Thank you, Ivar. That was awesome. Some really interesting to see where Unleash is heading next and what you're thinking about. And yeah, I think this really helps set the stage for what's coming next in the following talks. And especially this like big picture view of feature ops. This is going to be really useful as we zoom into some of the real world stories and insights from our customers.